The question of whether an instantaneous type water heater requires a disconnect mounted with it, such as under a sink, is a common one. National Electrical Code Article 422 addresses appliances and their disconnection requirements. Specifically, NEC 422.31 covers disconnection of appliances. 422.31 discusses readily accessible disconnecting means. Subsection 2, disconnecting means for appliances, states that an appliance rated at more than 30 amps shall have a disconnecting means installed near the appliance capable of disconnecting all ungrounded conductors. Based on this, if the appliance is rated at 30 amps or less, a disconnect is not required by this particular section of the NEC. In the instance of a 120-volt, 3 kilowatt water heater rated for 25 amps, because the unit is rated for 25 amps, which is below the 30 amp threshold specified in NEC 422.31 ATWO, a disconnect is not required. It is also important to consider the manufacturer's installation instructions. Typically, these instructions will specify any required disconnects. However, in this case, as there is no disconnect shown in the manufacturer's instructions, this is consistent with the NEC requirements, as a disconnect is not necessary for appliances rated below 30 amps. To summarize, based on the NEC and the manufacturer's instructions, an instantaneous type water heater rated for 25 amps does not require a disconnect mounted near it. The NEC mandates a disconnecting means near appliances rated over 30 amps. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information. Also, remember to refer to the specific manufacturer's instructions for the appliance you are installing, as these may have additional requirements beyond the NEC. When determining the correct wire size and overcurrent protection for an appliance, several factors need to be considered. Firstly, the nameplate rating of the appliance, including the voltage and amperage or wattage, is critical. This provides the baseline information for calculating the current draw and determining the appropriate conductor size. Secondly, National Electrical Code Section 430.22 and 430.24 provides guidance on the sizing of conductors for motor loads, but it can also be applied analogously to other continuous loads. It generally requires that the conductors be sized no less than 125% of the full load current of the appliance to account for potential overloads and continuous operation. Thirdly, the ambient temperature and the type of insulation used for the conductors must be considered. Higher ambient temperatures can reduce the ampacity of conductors, so temperature correction factors from NEC Table 310.15 need to be applied. Fourthly, the overcurrent protection, such as a circuit breaker or fuse, must be sized to protect the conductors and the appliance. NEC Section 240.4 specifies the rules for overcurrent protection, generally requiring that the overcurrent device be sized to protect the conductor's ampacity, but also allowing for the next standard overcurrent device size in certain situations, as long as it does not exceed the appliance's rating. The type of overcurrent protection should also be appropriate for the appliance, with some appliances requiring specific types of breakers, such as ground fault circuit interrupter, GFCI, or arc fault circuit interrupter, FSI breakers. Fifthly, voltage drop should be calculated to ensure that the voltage at the appliance remains within acceptable limits. Excessive voltage drop can cause the appliance to operate inefficiently or even damage it. NEC Informational Note Number 1 Table 210.19 AM provides guidelines on voltage drop, suggesting that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. Sixthly, the available short-circuit current at the appliance's location must be considered to ensure that the overcurrent protection device has a sufficient interrupting rating. If the available short-circuit current exceeds the interrupting rating of the overcurrent device, a fault could cause the device to fail to clear the fault, leading to potential equipment damage or safety hazards. When installing electrical equipment, it is important to adhere to the working space requirements outlined in NEC Article 110.26. Firstly, clear working space is required in front of electrical equipment, such as panel boards, disconnects, and control panels, to allow for safe operation, maintenance, and inspection. The depth of this working space depends on the voltage of the equipment and the conditions present, such as whether the equipment is exposed and energized. Secondly, the width of the working space should be at least 30 inches or the width of the equipment, whichever is greater, to allow for adequate movement and access. Thirdly, sufficient headroom is required in the working space, typically at least 6 feet 6 inches, or the height of the equipment, whichever is greater, to prevent workers from hitting their heads on overhead obstructions. Fourthly, the working space must be clear of obstructions that could impede access to the equipment, such as stored materials, piping, or other equipment. Fifthly, illumination is required in the working space to provide adequate visibility for performing tasks safely. Sixthly, dedicated equipment space is required above and below the electrical equipment, extending to the structure or suspended ceiling, to prevent the installation of foreign systems, such as piping or ductwork, in this space. The NEC requires proper grounding and bonding to ensure electrical safety and minimize the risk of electric shock. Firstly, grounding refers to connecting the electrical system to the earth to provide a low impedance path for fault currents. This is typically achieved by connecting the neutral conductor to a grounding electrode system, such as a ground rod or metal water pipe. Secondly, bonding refers to connecting all non-current carrying metal parts of the electrical system together to create an electrically conductive path. This includes metal enclosures, raceways, and equipment frames. The purpose of bonding is to ensure that all metal parts are at the same electrical potential, minimizing the risk of electric shock if a fault occurs. Thirdly, the grounding electrode conductor (GIC) connects the neutral conductor to the grounding electrode system. The size of the GEC is determined by NEC Table 250.66 based on the size of the service entrance conductors. Fourthly, the equipment grounding conductor (EG) provides a path for fault current to return to the source. The EGC can be a wire, conduit, or other approved means, and its size is determined by NEC Table 250.122 based on the rating of the overcurrent protective device. Fifthly, bonding dampers are used to connect different metal parts of the electrical system together, such as connecting a metal conduit to a metal enclosure. The size of the bonding jumper is determined by NEC Table 250.102 based on the size of the largest ungrounded conductor. Sixthly, ground fault circuit interrupters (GFCI) are required in certain locations, such as bathrooms, kitchens, and outdoor areas, to protect against electric shock. GFCIs detect small imbalances in current and quickly de-energize the circuit, preventing injury. When wiring an appliance, it is important to follow the wiring methods and materials specified in NEC Chapter 3. Firstly, conductors must be properly sized for the load they will carry, based on NEC Table 310.16, and must be suitable for the voltage and temperature conditions. Secondly, conductors must be protected from physical damage by using appropriate raceways, such as conduit or cable trays, or by using cables with a protective jacket. Thirdly, connections must be made using approved methods, such as wire connectors or terminals, and must be properly tightened to ensure a good electrical connection. Fourthly, the wiring must be properly supported and secured to prevent strain on the connections. Fifthly, the wiring must be installed in accordance with the NEC rules for clearances and separation from other systems, such as plumbing or heating. Sixthly, the wiring must be properly identified and labeled to indicate its purpose and voltage.